In this video, I'm going to go over do number 7. So let's get started. This is the do number 7. So here is the main story. A person is getting inside the elevator with a scale and standing up on the scale to see how he experiences differently when elevator going through 4 different scenarios. Number 1, when elevator is in constant velocity. Number 2, when elevator is accelerating up. Number 3, when it is accelerating down. And number 4, when someone cut the rope of the elevator. So what is person experiencing? The person experiencing same over here, because no apparent weight loss or gain. So elevator is constant velocity. The scale reads exactly 100 kilogram. When the elevator is moving up, accelerating up, then the scale do not read 100 kilogram. In fact, scale read 120 kilogram. Why 120 kilogram? Is because the person is accelerating up, person feels heavier. So the scale read 120 kilogram. When elevator accelerating down, the scale read 80 kilogram. Scale read 80 kilogram, and when someone cut the rope, the scale read 0 kilogram. So you see how scale read differently when person go through the different scenario, and that's what I'm going to help you understand on this video. So why don't I get started? All right. Number 1, the first thing first, I'm going to draw the free body diagram for all scenarios: scenario 1, scenario 2, scenario 3, and finally scenario 4. So free body diagram for all 4 scenarios. So the weight vector would be same. Weight is mg. All right, weight doesn't change. Weight does not change. One thing does not change, and that is the weight. And the weight would be mg. Mg is 100 times. We're gonna use 10. We're gonna use 10 as the question asks you to use 10. So that means 100 times 10 is 1000 Newton, 1000 Newton, 1000 Newton, and 1000 Newton. So one thing you see that even the scale read the different thing, even the elevator go through the different type of phenomena, the weight remain same. So that's exactly what you're going to write. You're going to write 10 raised to 3. We're going to use the different color. So 10 raised to 3, 10 raised to 3, 10 raised to 3, and 10 raised to 3. So this is the weight. Now we're going to try to find the normal force. As you know that scale only read the normal force, so normal force is going to be different. Normal force is going to be different. This normal force is going to be 1000 Newton. This normal force is going to be 1200 Newton. Is because the elevator is accelerating up. This normal force is going to be 800 Newton because the elevator is accelerating down, and this normal force is going to be 0. Normal force is going to be 0. Now let me help you understand why this is the case. So this one, Fn is equal to Fg, is because the net force is 0, is because acceleration is 0. So no apparent weight gain, no apparent weight loss. So this is going to be normal force going to be same. This one, Fn going to be is equal to mg plus a. So Fn going to be 100 plus 12. So Fn going to be 1200. So Fn going to be 1200. So I'm going to write 1200. This one Fn gonna be let's see, this one Fn gonna be Fn is equal to m g minus a. So Fn is gonna be m is 100, g minus a is 8, so Fn gonna be 800 Newton. So this one is 800 Newton. So let's write that down, 800 Newton. This one Fn is 0. Why this time Fn is 0? Is because Fn is 0 because someone cut the rope, elevator is in free fall. When the elevator is free fall, Fn is 0. So Fn is 0. Alright, now the next thing we're going to find the total acceleration. So total acceleration for this one is 0. So total acceleration, this one is 0. So you're going to write total acceleration 0. This one, total acceleration is 12. Why the total acceleration is 12? Let's try to understand that. So 10 plus 2. So 10 plus 2 is z plus a. So total acceleration is z plus a. So this one, total acceleration is g minus a, which is 8. So total acceleration is g minus a, which is 8. So g minus a, which is 8. And the total acceleration is z. What is the total acceleration? Total acceleration is z, 9.8 meter per second squared. So what is the total acceleration? Total acceleration is z. Okay, hopefully you understand that. So now we're going to find the net force. Net force is 0 over here. Why the net force is 0 over here? Because acceleration is 0. So net force is 0. The net force is 200. Why the net force is 200? Because net force is Fn minus Fg. So net force is Fn minus Fg. Fn is 1200 and Fg is 1000. So net force is 200. Now let's see the net force over here. Net force over here is negative 200. Why? Because net force is 800 and the weight is 1000. So the net force is negative 200. So net force is negative 200. Net force is negative 200 means it doesn't mean something wrong. Net force is negative 200 means acceleration is downward. Acceleration is downward. So what is the net force over here? Net force is 1000 Newton, and make sure you put negative. So net force is negative 1000 Newton means nothing wrong. It only means that acceleration is 9.8 downward. Okay, so that's what it means. 9.8 1000. Okay, now let's do the next one, apparent weight loss. Now let's do apparent weight loss. Apparent weight loss is 0. Apparent weight loss is 0 over here, so 0. Apparent weight, the next one is there is apparent weight gain over here, no apparent weight loss, so it does not apply. So apparent weight loss, the next one, yeah, apparent weight loss. There is a apparent weight loss, and apparent weight loss is the actual is 1000 kilogram. The person is 1000 kilogram, but scale read the person is 100 kilogram, but scale read 800 kilogram. Scale read 800 kilogram, 80 kilogram. So scale read 80 kilogram. All right. So apparent weight loss is 20 kilogram. So 20 kilogram. Apparent weight loss, well, scale read 0. Scale read 0. So apparent loss is 100 kilogram. Alright, now we're going to find the apparent weight loss. Apparent weight loss is 0, not essential. And 200 kilogram. 200 kilogram is 200 Newton. Oh, this is in kilogram. The other one is Newton. Oh, oops. This one is in Newton. So this is 200 Newton. This is 200 Newton. And this is 1000 Newton. 1000 Newton. So now is now we're gonna write in kilogram. 200 Newton is 20 kilogram. All right, 1000. Oh my God, 0 is missing. So the space is so small. So it's 100 kilogram. Apparent weight loss. Apparent weight loss is 100 kilogram. All right, now apparent weight gain. Apparent weight gain is 0. Why apparent weight gain is 0? Because the net force is 0. Apparent weight gain over here. Apparent weight gain in Newton is 200 Newton. Why apparent weight gain is 200 Newton? Well, it's because the person is accelerating up and there is a total acceleration of 12. That's why. Apparent weight loss, there is no apparent weight loss. And apparent weight loss, there is no apparent weight loss. Okay. Alright, now let's see. No apparent weight gain. No apparent weight gain. So apparent weight gain in going to do apparent weight gain in kilogram. Oh, so this one is yeah, so 200. So this is going to be 20. All right, this is going to be apparent weight gain is 0, and apparent weight gain when accelerating downward, apparent weight gain is 0. Well, not essential. It's moving downward, and apparent weight gain not essential. So now the person will have, the person feels same, the person will heavier. The person will feel lighter, weightlessness. All right, thank you.